Hello everyone. For this video we're going to be taking a look at some applications of the right triangle trigonometry that we've been learning about so far. And so as you can see in the objective here, we're going to solve some right triangle problems by correctly selecting and using the tangent sine and cosine ratios. So one of the first things we might want to remind ourselves of is what are the definition of these sine, cosine, and tangent ratios. And if you remember, we have a nice easy way of remembering what the definitions of sine, cosine, and tangent are, and that is by using SOHCAHTOA, that little mnemonic device SOHCAHTOA, which tells us that the sine is the opposite, oops, two O's there, the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. And so as long as we remember how we determine what the opposite side is and what the adjacent side is and what the hypotenuse is, this should be a nice easy way of remembering what the definition of sine, cosine, and tangent are. So let's jump right into our first problem here. It says when the sun's angle of elevation is 38 degrees, a building casts a shadow of 45 meters. How high is the building? And one of the first things you always want to do when you're working on an application problem like this is to draw yourself a quick little sketch. Now I was just having a little bit of fun with my drawing program, and so I made my sketch in color and kind of tried to make it a little bit three-dimensional. Yours obviously does not have to be elaborate. It just has to be something that you can look at to visualize the information that the problem is giving you. So what this is telling me is that the sun's angle of elevation is 38 degrees. I'll come back to that in a second. But it says that the building casts a shadow of 45 meters. So here's my sun here, and it's shining down on my building, and it's creating this shadow right here, which is 45 meters long. So from here to the building, that is 45 meters. Now, what is this angle of elevation telling me? Well, that would be telling me that from the tip of the shadow there, from the end of the shadow, if I draw a straight line, as straight as I can draw it, a straight line up to the top of the building, that line, let me see if I can make that a little bit straighter, that line is at a 38-degree angle with the ground. You get the idea. It's not the straightest of lines, but you get the idea, and it's a 38-degree angle with the ground. And again, what the problem is asking me for is how high is the building. It's asking me for this height right there. Instead of putting a question mark, let's go ahead and label it as H. So this is the information that I have in the problem. A 38-degree angle of elevation, a 45-meter distance from the end of the shadow to the building, and I'm looking for this height right here. Now, I guess we can assume that this is a right angle right here. We're going to, for the purposes of this problem, we're going to say that that's a right angle. The angle that the building makes with the ground is a right angle. It's not the Leaning Tower of Pisa or anything, I guess. And so you can see that sets up a little right triangle that we have. And since I know the measure of this angle, then I might want to label these two sides using these terms of opposite, adjacent, hypotenuse, whichever ones are appropriate, for this angle. And that should give me an indication of what trig ratio I might want to set up. So let's go ahead and label those. Let me get a different color here. This H, the height of my building, is across from the angle that I know, right? It's across from the angle I know. So that tells me that is the opposite leg. Of course, if here's my right angle, this right here is my hypotenuse, but I don't know anything about the hypotenuse. I also know that this measurement right here is 45, and if here's the vertex of my angle, that would be the length of the adjacent leg. So you can see in this problem, from the perspective of my 38-degree angle that I know, I am looking for something that would involve the opposite leg and the adjacent leg. So if I come up here to my definition of sine, cosine, and tangent, the one that should be jumping out at me is the tangent ratio because it uses those two things, opposite leg and adjacent leg. So that's my indication that I want to solve this problem by using and applying the tangent ratio. So I'm going to set my problem up by saying that the tangent of my 38-degree angle I know is going to be equal to the opposite, which is H, divided by the adjacent, which is 45. Now I have an equation that just has one variable in it, so I should be able to solve for this. I'm going to put my tangent of 38 over 1 and cross multiply. So the h is going to get multiplied by 1, leaving me with just h all by itself. That's a good thing. And then these two parts get multiplied together. And so the way we write that is 45 tangent 38. So my hypotenuse is equal to 45 times the tangent of 38. And I can grab my calculator and I can type in 45 tangent 38, just like I wrote it. And it's going to tell me that h, and I'm going to round this, so I'm using the approximately sign. H is approximately, I'll go to the nearest whole number. Looks like it's about 35, and then my unit was meters. So the height of the building is about 35 meters. So we drew ourselves a sketch. We looked at what parts of this right triangle that resulted from our sketch. We looked at what parts we knew or were wanting to know, and that information hopefully guided us towards this usage of the tangent ratio. Let's take a look at example 2. It says a ladder 32 feet long rests against a building and makes a 75-degree angle with the ground. Left out a word there. A 75-degree angle with the ground. How high above the ground is the top of the ladder? So in my little sketch here, I know here's the ladder and here's the building. Again, I can assume that that building is making a right angle with the ground. I know that this ladder is 32 feet. And I know that this angle, the angle that the ladder and makes with the ground, is 75 degrees. And I want to know the height above the ground where the ladder makes contact with the building. So if I label these two sides, the sides that I know and I'm interested in, from the perspective of my 75-degree angle, I know that the 32 feet is going to be my hypotenuse because it's across from this right angle right here. So that's going to be my hypotenuse. Let me change back to blue. That's going to be my hypotenuse. And this h is across from the angle that I know, so that is going to be my opposite leg. So now again, from that definition of SOHCAHTOA, from that little mnemonic device that we have, if I am looking for a ratio that involves opposite and hypotenuse, the sine or SO part of SOHCAHTOA should jump out at me. I want to use sine ratio. So I'm going to write sine of my 75-degree angle is going to be equal to the opposite leg from the 75-degree angle, which is h, over the adjacent of the right triangle, over the hypotenuse of the right triangle, which is 32 feet. So I put that over 1, I multiply the h times 1 to give me h, and that's going to be equal to 32 times the sine of 75, so I'll write that 32 sine 75, and I'm going to grab my calculator and I'm going to type in 32 sine 75, and it tells me it's about 31 feet. So that ladder is going to hit the building at about 31 feet above the ground. And again, we just had to look at which parts of this right triangle do we know and which part do we want to know. And that should guide us towards choosing the correct ratio, whether it's sine, cosine, or tangent. Lastly, we got example 3 right here. And this one says a department store's escalator is 82 feet long and takes shoppers from the first floor to the second floor. The second floor is 32 feet above the first floor. What angle does the escalator make with the floor? So here I have my sketch of my escalator going from my first floor up to my second floor, and the problem tells me that that escalator is 82 feet long, and that the distance from the second floor down to the first floor is 32 feet. So if I extend this line for the first floor over, and I drop a line down from where the escalator reaches the second floor, you can see that should be a right angle right there, meaning I have a right triangle, and I know that this distance is going to be 32 feet. And it's asking for the angle the escalator makes with the floor. Well, that would be that right there. So we'll go ahead and call that's x degrees. That's the thing we're looking for, the measure of that angle right there. So from the perspective of that angle, I know that, of course, this over here will be my hypotenuse because it's across from the right angle. So that's my hypotenuse. And this is my opposite leg. So the two parts that I know about this triangle are the opposite leg and the hypotenuse. So in SOHCAHTOA, that would be, again, the sine ratio. So I'm going to set up the sine of whatever x is will be equal to opposite, which is 32, over hypotenuse, which is 82. And since I want to know the angle measurement, I'm going to rearrange this equation, and I'm going to use the sine inverse of this 32 over 82 ratio, and that should tell me the value of x. And again, when I want to use sine ratio, I got to make sure I hit the second function of my calculator. So I'm going to hit second sine, and then I'm going to type it in, 32 over 82, and remember to close the parentheses that my calculator opens up for me. So 32 divided by 82, and then close the parentheses. That tells me that x is going to be approximately, looks like it says 22.9696, so we'll go ahead and round that to about 23 degrees. So that angle is about 23 degrees. So you can see the key to these application problems is, first of all, drawing yourself a picture to give yourself something to look at. Then once you have the parts of the picture labeled, you're going to want to kind of make a judgment about which ratio you could use based on the parts that you either know or that you want to know, whether it's going to be sine because opposite and hypotenuse are involved in that problem, or it's going to be cosine because the adjacent and the hypotenuse are involved in the problem, or it's going to be tangent because the opposite and the adjacent are the parts that are involved. All right, so good luck with these problems, and we will see you next time.